Good morning all. Today we are going to discuss about the fourth unit, design of gearbox in design of transmission systems. So let's directly jump into the topic. The introduction. A transmission or gearbox provide speed and torque conversion from rotating power source to another device using gear ratios. Gearbox are used to reduce the load on the motor, and it also can provide multiple varying speeds using a single input. This reduces wear on the engine, allows more control and allow greater speed and varying speeds. There are different types of gearbox: a sliding mesh gearbox, constant mesh gearbox, and synchro mesh gearbox. The first is a sliding mesh gearbox. So the sliding mesh gearbox is the simplest construction and the basic gearbox used during the introduction of gearboxes. So this is a schematic representation of the gearbox. When the driver adjusts the gear lever to engage the gear, the rotating gears in the input and output shaft, the output shaft will slide through the splines and get meshed with the lay shaft gears. So this is the basic operation of the sliding mesh gearbox. The major disadvantage of the sliding mesh gearbox is rough engagement, and it can easily damage the teeth in the gears while engaging a sliding mesh gearbox. The next is the constant mesh gearbox. In constant mesh gearbox, this is a schematic representation. It is almost similar to sliding mesh gearbox, but the gear set is already fixed with the pair, already connected with the pair. In the input as well as the output shaft, all the gears are respectively connected to the necessary gears available there. The only difference is there is a separate dog gear available in between the connected gears. The dog gear engaging a particular pair, that particular power will be given to the transmission. So this also has a same disadvantage. The teeth in the dog gear can easily get damaged. The next is the synchro mesh gearbox. This type of gearbox is used in nowadays manual transmission cars. In a synchro mesh gearbox, there is a special unit called a synchronizer, which will match the speed of a rotating gear so that the gears can get meshed in a smooth manner. The requirements of a speed of a gearbox: it should provide the designed series of spindle speed. It should transmit the required amount of power to the spindle. It should provide a smooth, silent operation of the transmission. It should have simple construction. The mechanism of the speed gearboxes should be easily accessible so that it is easier to carry out preventive maintenance. So there are certain design procedures. Before seeing that, the speed in the machine tool gearboxes are in geometric progression. The speed in the gearbox can be arranged in an arithmetic program or geometric progression, harmonic progression, or logarithmic progression. So there are certain procedure for designing a gearbox. So first step, the selection of a spindle speed. We have to determine the progression ratio by using the formula here. With the help of a given data, we can find the maximum and the minimum speed that the gear can transmit. Using that, you can find the progression ratio. After finding the progression ratio, use the PSD data book page number here, and we can find the series of speed the gear can transmit. After finding the speeds, you have to write the structural formula. The writing structural formula, you can see that Z1, that Z is equal to P1x1, P2x2, P3x3. There are different types of speeds provided here: 6-speed gearbox, 8-speed gearbox, 9-speed gearbox, 12-speed gearbox, and 16-speed gearbox. In a 6-speed gearbox, you can split it into 2 into 3 concept. In the 8-speed gearbox, you can split as 2 into 4 or 4 into 2 or 2 into 2 into 2. For 9-speed gearbox, you can split into 3 into 3 concept. 12-speed, you can split into 3 type of variations, and 16-speed also we can split into different types of variations. Here, for example, 2 into, for in 6 speeds, if you are splitting as 2 into 3, 2 is P1 and 3 is X2. So in that concept, we are going to split it. The step 2, we have to draw the ray diagram. So drawing ray diagram, for the drawing ray diagram, we have to choose the structural formula. For example, if you are taking 3 into 2 concept for 6-speed gear, P1 X1. Okay, so in that concept we have to draw. Here there are 3 stages for a 6-speed gearbox: stage 1, stage 2 and stage 3. Here you can see P1 X1 then P2 X2. So P2 X2, here X1 there is value, X2 there is separate value, X3 there is separate value. For a 6-speed gearbox, it will come as the 2.6 gap concept. So the first point you have to keep in N1 and you have to leave 6 gaps, and then you have to keep the next point in N7. After keeping 2 points, you have to find the center of these 2 points, and correspondingly in the stage 2, in the near the next point upside to the center point, you have to place the point and you have to connect it. So likewise, you have to connect the complete sequence. After connecting the complete sequence, in the center line you will get 3 points, and you have to just connect the 3 points with the first point in the previous line. After drawing the ray diagram, you have to draw the kinematic arrangement of the gearbox. In this arrangement, it is given that 3 into 2 into 2. 3 into 2 into 2. In the first input shaft, there is 3 gear, and in the intermediate shaft, the corresponding 3 output as well as a new 2 input, and in the next third intermediate shaft, the corresponding 2 outputs and a new 2 input, and finally in the output shaft, the final 2 outputs are available. So these are the steps for designing the gearbox. So I will catch you with a new topic in the next video. Thank you.